Alright, here is your video about limiting reagents, and it's about stoichiometry as well, so it's very, very similar to what we've been doing, and it's about finding out how much product you're going to get when you mix two different reactants together. We've got a few key words we want you to understand, and then we'll get into the nuts and bolts of what it's all about anyway. So let's have a look at this. We've got mole ratio. You should know what that means anyway. It means the ratio that is in the chemical equation of reactants to products. And you should know how to use that from your normal simple stoichiometry that you've been doing so far. You should also understand what limiting reagent means at the end of this podcast. The limiting reagent means it's going to be the reactant which runs out first. Then you have excess. Okay, when we're mixing two things together, one reactant will run out, which will be the limiting reagent, and you'll have some left over, which is going to be your excess. Your LR ratio, I'm going to get into that in a bit later on, obviously not just now, and then reactants to products. And they're the key words we're going to look at throughout this whole podcast. So let's have a look at what limiting reagents are. Okay, we'll compare it to what we've been doing, our simple stoichiometry. What we're doing with our simple stoichiometry is we're imagining that reactants are mixed in the perfect ratio so that the reaction works perfectly. Okay, or we assume that one of the reactants will never run out. Okay, in these questions you normally just have one reactant which is specified, or you have a product which is specified, saying how much of this stuff do you need to make a certain amount of product. That doesn't normally happen in real life. Normally what you have is you start off with two reactants and you mix them together. One of them is always, or almost always, going to run out first, and that's where the limiting reagent comes into it. Okay, and to understand which one runs out first, and that will allow you to realize how much product you're going to get from a certain reaction. Because the one you run out first is going to be the one that the reaction depends on. So your limiting reagent is kind of like your dependent variable. It's what you use to determine your products. And we use a limiting reagent when we have two reactants which will be added to a beaker, or two reactants which will be reacted together. And we have information about two reactants. Let's have a look at how it works. Here's a basic diagram of a limiting reagent question. It's to do with hamburgers, because everyone likes hamburgers. Sorry for the vegetarians and the vegans out there, but we're using meat patties for this one anyway. We've got 4 buns. We've got how many? 1, 2, 3, 4, 5, 6 pieces of cheese, 3 lots of lettuce. It looks like cos lettuce or something like that. And then we have 5 burger patties. Okay, how many burgers will be made? What we need to look at is what's going to run out first. And we understand that quite easily with this example here, we can see that our lettuce here is going to run out first. This is known as your limiting reagent. Okay? Your limiting reagent is something that is going to run out before all the others. So in this burger example, our limiting reagent is our lettuce because it runs out first. So that means our total products, or our total burgers, are going to be only 3, because we can only make 3 because we have our 3 lettuces here. Alright, let's move on and let's have a look at a chemical example. And it's a very simple example of making water from hydrogen and oxygen, where we have an explosion. What we have is, our example is 4 moles of hydrogen and 3 moles of oxygen are reacting together. How much water would I be able to obtain from this reaction? We've got to look at our ratio here, and we say that 2 moles of hydrogen will react with 1 mole of oxygen to form 2 moles of water. So I've got our examples here. I've got 4 moles of hydrogen here. I've got our 3 moles of oxygen here. Our ratio here says we're going to have 1 and 2 of these hydrogens reacting with one of these, and that's going to produce 2 waters. So let's do that now. So we'll burn off 2 of these hydrogens and 1 of these oxygens, and we make 2 waters. Okay. Next up, we've still got 2 hydrogens here, and we've still got another water, so let's burn those off. And we make 4 waters, and now we've run out of hydrogen, so there's no more hydrogen that can be used. We've got 1 mole of oxygen that's left over. So what we have is our limiting reagent is our hydrogen because it ran out first, and our oxygen is in excess. And it's in excess by 1 mole because we have 1 mole of oxygen left over. How much we produced? Okay, it was 4 waters, and that's based on our limiting reagent. So, as I said, this the amount of product we get is based upon our limiting reagent because that is what is telling us how much it's limiting how much of this can be produced. So what this means, what does this mean in terms of calculation? What this means is each time you have 2 reactants or an amount of 2 reactants that are reacting together, you need to find out which one is going to be the one that runs out first. And then you can do your ratio calculations to find out how much you produce. This is very, very important because if you don't, you're going to think you produce more than you actually can. So let's have a look at how we do limiting reagent questions in terms of stepwise working that out. And then I've got a few videos that you can look at for worked examples of solutions for them. So where the limiting reagent fits in terms of our steps. We always start off with writing an equation. Okay, that's always going to be step 1. Step 2 is converting to moles. Okay, you're always got to convert to moles. What happens then is once we've converted to moles, our 2 reactants, we then need to find out which one's going to run out first. Okay, this is your new step for when you have a limiting reagent, when you have 2 reactants reacting together. Okay, you need to find out which one is going to run out first using a limiting reagent ratio. What you're then going to do is use your limiting reagent to find out your unknown number of moles and then convert it to what your question asks for. The only thing we're adding in here is this step here. And then we're going to use our number of moles of limiting reagent to find out our unknown. So that's our stepwise for this. And it's going to make a lot of sense, a lot more sense when you look at my examples of how to actually tackle these problems and the steps and the setting out that I put into it. So what you probably should look at doing is pausing this now or stopping this and going on to looking at the worked examples. Okay, you can see these examples either on the Dropbox for my class or they'll also be on YouTube as well. So if you type in mrjasongoudie on YouTube in the search, you'll come up with all the videos and you'll see my channel on YouTube there. So you can see these either way. So anyway, after you've looked at that, you're going to look at this summary, and this should make a lot of sense to you. You're going to understand that not all reactions have a perfect stoichiometric ratio, that sometimes you have 2 reactants reacting together, and one of them is going to run out first. And this is called the limiting reagent. Okay, the limiting reagent runs out first. And you use a limiting reagent ratio when you have 2 reactants reacting together. The excess amount will be the leftover. What is left over? The excess reactant. We use a limiting reagent in all calculations. So you've looked at the examples and you'll understand that what we do is when we're calculating how much is going to be produced, we use the moles of our limiting reagent. We use a limiting reagent ratio to determine the limiting reagent, and each time you must show clear working out, just like I did in my examples. Okay, it's very clear how I wrote down what I was calculating out in each step, so then it's very clear when you go over it, and it's very easy to understand anyway. So that's our summary. Not all reactions have the perfect ratio. We need to use a limiting reagent ratio when we have 2 reactants reacting together, and you must always show clear working out. Moving on to some questions that you can do. Here are your questions from the textbook. Okay, it's page 271, and there's only about 6 or 7, 34, 35, 36, 37, 38, 39, 6 questions on limiting reagents in there. I might even put together a few other questions and put them on Edmodo, but I'm not too sure yet. But these are the minimum questions that you need to do for limiting reagents, because this will be part of your exam. We'll be tackling a limiting reagent question and showing all your working out for these questions. And that's it. That's all I've got time for. And hopefully if you have any questions on this, you can send me an email or ask me in class about this type of stuff. So have a crack at these questions and then check your answers, make sure you're on the right path, and then if you are having difficulty, come and see me. Till then, goodbye.